Alright guys, so we need to take the fourth root of 625, and we're actually taking the fourth root of every single thing inside of here. Okay, so taking the fourth root of 625, what do I get? Does anybody know? 5. It's 5 times 5 times 5 times 5. Okay, so this is going to be the same as 5 to the 4th times x to the 8th times y to the 4th times z to the 12th. So all I did was I rewrote it as 5 to the 4th. And this is the same, fourth root, sorry, as splitting every single one of these up. So we can actually take the fourth root of each one of these. So this is the same as fourth root of 5 to the 4th times the fourth root of x to the 8th times the fourth root of y to the 4th times the fourth root of z to the 12th. Okay, I'm only going to write it all the way out this one time, okay? Just to show you guys that it's all the same. So what would the fourth root of 5 to the 4th be? 5, right? Okay, what about the fourth root of x to the 8th? How many groups of 4 are in there? 2. So this is going to be the same as x to the 2nd. How did I get that? 8 divided by 4 gives me 2. What about y to the 4th? That's just y. And what about z to the 12th? 3, right? 12 divided by 4 gives me 3. So we have actually an even amount of groups of 4 in this case, right? So this is my answer. That's it. Okay? That's all I need. But what if we don't have an even amount? So let's look at example 2. Now I know it's really blurry. Okay, I know it's really blurry, but we're taking the cube root, so the index is 3, of 27, a squared, b to the 7th, c to the 4th. Is 27 a perfect cube? Yeah, what times itself 3 times gives me, good, 3. So we can actually pull out, actually I'm going to first rewrite it as just 3 cubed, a squared, b to the 7th, c to the 4th. And this is just going to come in handy later on. Okay, so that's why I'm doing it now, just to get us used to it. Okay, so 3 cubed, cube root of that is just 3, right?
Yep.
Okay, what about a squared? Are there any groups of 3 in there?
No.
No. What about b to the 7th?
No.
Are there any groups of 3?
No.
There's 2 groups of 3, right? 7 divided by 3, I can have how many times equally? B to the 2nd, right? What about c to the 4th? How many groups of 3 are in there? 1, so it's just going to be c. Now this is very similar to what we were doing before. We still have some that are left inside of that cube root. What are they?
A squared.
A squared. How many b's did we leave behind? 1. And how many c's? 1. So we would have 3b squared, c cubed, or c, I'm sorry, I did this the other day, earlier today too. C cube root of a squared b c. Okay? So all I did here was I divided the exponent by the index. I took out all of the whole numbers, and I left the remainders inside. Does that make sense? Yeah? You okay with it? Okay. Let's look at example 3. I have a radical in the denominator. Is that allowed? No. Now before, when we had something like, I don't know, 3 over square root 2, how did we get rid of that square root 2? We multiplied, we don't need a conjugate in this one. We just multiply by square root 2, right? Because then this would give me 3 square root 2 over 2. Now, this is very similar, but we're not taking a square root, we're taking a fourth root. So one thing that is going to be really helpful to us is to first factor out what's inside that root. So let's factor out 27 and see what happens. If I factor 27, I'm going to do it off to the side here. That gives me 3 times 9, and 9 is 3 times 3. So I'm going to first rewrite this. 15 over 4th root of 3 cubed. Is everybody okay with that? Because I have 3 to the third 3 times? So 3 cubed. Okay, that's 3 3s. Now, how many 3s am I away from getting 4? Just 1. So I can multiply this guy by the 4th root of 3. Just 3. What would happen then? Let's look. Okay. In the numerator, what would I have? 15, 4th root 3. In the denominator, the 4th root of 3 cubed times the 4th root of 3. What would that give me? The 4th root of 3 to the what? To the 4th. These cancel out, right? So what would I get for my answer? 15, 4th root 3, all over 3. And then these reduce, right? You guys are getting a little bit ahead of me. These reduce. 5, right? So my answer is 5, 4th root 3. So it actually helps us on this one to factor it out first and see how many groupings of 4 we already have before we start. Okay? Does that make sense? Yeah? Let's try another one.
What was the homework that was supposed to be yesterday?
Point 1. Yeah. Okay, so let's try another one. Example 4. And then we'll be done. It's a cube, yeah. It's the cube root of 3/4. No, it's today. I'll explain it in just a second. Okay? This splits up. How does this split up? Cube root of 3 over cube root of 4. Now, let's factor out 4. 4 is what? 2 times 2. So that's the same as cube root 3 over cube root of 2 squared. How many 2's am I away from having 3?
1.
Just 1, right? So I'm going to multiply the numerator and the denominator by the cube root of 2. What does that give me? That gives me cube root of... Can I multiply these two guys together? Yeah, so that's going to be cube root of 6 over cube root of 2 to the 3rd. And those guys cancel, right?
Yeah.
These two guys? So it's going to be cube root of 6 over 2. Now, can I pull any cubes out of 6? I'm going to factor it really quick just to check. 6 factors to 3 times 2. There's no groups of 3 in there, right?
No.
So this is as simplified as possible. So this is my answer in the green.